Yeah, great question. So this basically boils down to this single reversible reaction that's happening all the time in both directions in your body. Hydrogen plus bicarbonate goes to water and CO2, and this is your bicarbonate CO2 buffering system. And the idea is your body uses bicarb to maintain a stable pH. You will use bicarb to buffer that by binding to it and producing more H2O and CO2. Crucially, you can then breathe out this extra CO2. And you see this in someone with a metabolic acidosis. They will often hyperventilate. And the reason they're hyperventilating is because they're trying to remove the CO2 from this side of the equation to help drive the equation this way. So they will use their bicarbonate to mop up those extra hydrogen ions that are causing the acidosis. If you remove bicarbonate, then you not only do you have fewer ions available to buffer the hydrogen ions that are there, but you will also encourage this reaction to go in this direction, and you'll have a production of hydrogen ions which will make you more acidotic. Likewise, if you retain CO2 because you're not breathing properly, which will push the reaction in this direction, so you will produce more hydrogen and more bicarbonate. Now, the next question you might be thinking is, if I'm producing an equal amount of bicarbonate and hydrogen ions, why do I become acidotic? And the reason is your concentration of hydrogen ions is measured in nanomoles, but your concentration of bicarbonate is in millimoles, which means you are dealing with concentrations 1,000,000 times higher of bicarb than you are of hydrogen ions, which means if you produce one ion of each, it's going to have a bigger impact on the one that has a much lower concentration than it is in the one that's already got a lot of it hanging around. So one hydrogen ion changes the concentration of the hydrogen ions more than one bicarb ion changes the concentration of bicarb ions, if that makes sense.